Okay, for this video here, we're going to talk about how to write an explicit equation and recursive equation for the following pattern. And then the first term of the sequence is this, and then the next term is 3, and after every term that is found, multiplying by 3. So the first thing that I'm going to do when I do this problem is it tells me that I need a recursive and explicit equation for this. So because I get lost in all of these directions, the very first thing I'm going to do is I'm going to say, okay, I need an explicit, and then I need a recursive, and then, okay, and then I'm done. Okay, so here it says the first term in this geometric sequence. Oh, it's a geometric sequence. Very cool. Because it's a geometric sequence, then that means it should tell you a couple things, right? It should tell you a couple of things, right? So in the chat, can you tell me what's one of the things that, because it's a geometric sequence, what do I know? In the chat, if you can tell me what's one of the things that you know because it's a geometric sequence. So exactly. So someone put in the chat, I don't know why this is not showing up. I'm in the right place. So someone put in the chat that we know because it's a geometric sequence that we're going to be multiplying. So I'm going to write that out here because I want these notes to be in your head. So I'm going to write, sorry, I just copied my formatting over. So geometric means multiplying. So like before, if you saw like with, if you think about the Scott's push-ups problems, right? He's adding 2 to every single day. Here he's going to be multiplying. So instead of having a constant difference, we're going to have a constant ratio, which means it's a multiplier. That's the word that I'm going to have you guys use for now. It's a multiplier. It's a constant multiplier. So instead of me adding 2 to get to the next term, I'm going to be multiplying. And so because I'm going to be multiplying, I'm going to draw that table that I really like drawing. I'm not drawing it. I'm actually going to do this. That. Okay, so here, I'm just going to say this is the term. This is the n. This is your f of n, right? It's supposed to be lowercase. And then this is just going to be how I got that. So it says the first term in this geometric sequence is 1. Okay, so let me go to 1, 2, 3, 4, 5, 6 really quick. Okay, the first term is 1. Boom. Okay, the next term is 3. Okay. And then every term after that is found by multiplying the previous term by 3. So that right there, no. Oh, I know why. Okay. So that right there tells me that I am going to be multiplying by 3 at every single interval, right? So here, when this told me, this right here, multiplying the previous term by 3, this is saying, this is my constant ratio or your multiplier. Now, if you remember the guy before, our constant difference, he was the main star of the show. Same with the constant ratio in geometric land, right? So it's just a constant multiplier. So as you can see, we multiplied by 3. We multiplied by 3, and we multiplied by 3, and we multiplied by 3, right? Okay, so what's the next guy gonna be? In the chat, can you tell me what's the next guy gonna be? Sorry, I am gonna collect participation, guys. I am making this out loud to you so that you all see that this is legit. Very good. Yes, exactly. So yes to that and yes to that. Thank you for participating, and yes to your earlier ones. Exactly. So wait. So our next term here, remember, it says that you're gonna multiply by 3. So if this guy is 3, what is this guy gonna be? So I got a couple yeses, yes, 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 good job. And then I got a couple people who are a little bit off. And I want to make sure that everybody tries. And again, this is one of those things that I need you to hear me on this very, very clearly. Please hear me, please. Are you hearing me? Are you hearing me on this? Try. When you try and you mess up, remember, this is my favorite phrase. We fail in practice. The more we fail in practice, the more we learn, enabling us to succeed when it matters, right? So let me collect all this really quick that I got. Nayeli, sorry, I'm saying names out loud. Very good, very good. Okay, so yeah, your answer should have been 9. Our next number is 9, right? If you put not 9, where did you get your number from? Right, where did you get that number from? Okay, so yes, it's 9. Miss Johnson, why is it 9? Well, it's 9 because, right? It's 9 because 1 times 3 gave me my 3. Therefore, 3 times 3 gave me my 9. So all I'm doing is I'm multiplying by 9 every single time. Okay, it's going to be a geometric. And some of you are pretty fancy and you remember, like, oh, Miss Johnson, I remember like the structure of a geometric sequence. Good. Okay, so let's continue really quickly. I'm going to continue. So what would the next term then be? What would the next term then be? Yes. Yes to yes, yes. So some of you are yeses and some of you are no's. So if you said 27, yes, right? If you said a different number, we're not adding. Okay, this number, the next number is going to be 27 because we're multiplying 9 by 3 to get that number. See? Multiply the previous term by 3. Yeah, very good, very good. Okay, good, good, good. So, and then I'm going to continue on. This guy becomes 81, and this guy becomes 243. Okay. So then over here, what I want to write down, and I'm going to erase this part, right? I'm just going to write it small to the side here so I can write my little thing. 3 times, 3 times, 3 times, 3 times. Okay. So what I want to do here in this last little row or column is I want to start writing out the like how to break this down. And you've seen me do this a couple of times. So remember, I told you your first level of understanding is like, oh man, Miss Johnson, geometric means I'm going to be multiplying over and over and over. You're right. Your second level of understanding is going to be breaking this down into those multiplication pieces. Okay. So here, if you notice this guy right here, the way we got 3 was we did 1 times 3. Right? 1 times 3. In the chat, can you tell me what this one becomes? In the chat, can you tell me how to rewrite this one? Yeah, exactly. Very strong work here, people. Very good. And for those of you who say, Ms. Johnson, do I have to put that one? I do, because you'll see the pattern that I want you to see. And that one is going to make it very, very obvious. Very good. Okay. So no, I wouldn't write that. Yeah, and that's eventually going to be the answer. Very good. Okay. So I would write it as 1 times 3 times 3. Ms. Johnson, do I have to put that 1 there? I would, because you're going to see that come up in a second. And you're going to be like, oh, that's why she wants us to do that. Okay. And then continuing, if this guy would catch up to me. And then continuing, how would you write 27? How would you rewrite 27? So for those of you who are at that next level, Ms. Johnson, do I have to write this column? No, no, you don't. I'm writing this column to help the people along to move this. Yes, yes. Someone asked, hey, Ms. Johnson, can't we rewrite this with an exponent? Yes. Yes, very good. Very good, Nayeli. Very good, Caitlin. Good, 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 good. Okay, so yes, if you didn't know how to rewrite 27, you're writing 1 times 3 times 3 times 3. If you notice that 1 is staying the same, That 1 is staying the same. And your brain should be going like this. Where did that 1 come from? Because if I know where that 1 comes from, then when I write my explicit equation, I know what to write part of it. Okay. Okay, continuing on. Okay, I'm going to stop right here because I think you guys get it. I'm going to go with the 1 and I'm going to go with my times 3 times 3 times 3 times 3. Your brain should be asking 2 questions. Number 1, what is staying the same? The second question your brain should be asking is, what's changing, right? What is changing in all of these things? Okay, so if you said, Ms. Johnson, I noticed that 1 being the same the whole time. Very good. So let's start writing our explicit equation. We're going to build it. So when I build my explicit equation, okay, when I build my explicit equation, it looks like this. Sorry, hold on a second. It looks like this. So f of n is equal to that 1. Ms. Johnson, why that 1? Because that 1 kept showing up over and over again. Exactly. Okay, let me add a row to this really quick. Okay, so here for me, for n, that's what I want to do. My goal is to find n. Like, what's the rule for n? Okay. What else do you see that is the same? What else do you see that is exactly the same in all of these? Exactly. Who else? Come on. This is not just a me and that person. It's not just me. It's me, you, and you, and you, and you. So anybody who's trying to improve their grade on this, lock in right now, because this is the new part, right? Exactly. Okay. The thing that keeps staying the same are those 3s, Miss Johnson. Oh, okay, very good. So should I write a 3 here? Yes, write a 3. Okay, now we move to what is changing. Okay, and this is why someone else asked, hey, Ms. Johnson, can we rewrite this using exponents? And the answer is yes. Remember my little dramatic self last time was like, oh my gosh, I wish there was another way that we could write all these 3s. It's so forever, right? And you all said, yes, Ms. Johnson, we can. So can you rewrite these? Can you rewrite these using exponents for me, please? Can you rewrite these using exponents? So for those of you who are keeping track, if you've been answering every single one of my questions, you will not have to study for this section, okay, for this lesson. But that means you have to try. So for those of you who are like, oh, Ms. Johnson, I don't want to be wrong. No one can see your answers except for me, okay? All right, all right, all right. So how did you rewrite this? Like, let's pick one. For 27, how did you rewrite this line right here? What did you write instead? Yeah. So I see 1, I see times, I see 3 to the 3rd. So for those of you who forgot what an exponent is, an exponent tells you how many factors there are. How many factors? So if this makes sense to you, can you take a risk right now and tell me what you would rewrite for this one for 81? Take a risk, right? What stays the same? What changes? Take a risk. If you take a risk now and get your mistake out now, I promise you, it won't happen during the quiz. No, that's perfect. For those of you who don't know how to type it in the chat, the way you're typing it in is perfect. Nice. Okay, so I already know who is going to ace this part of the quiz. Nice. Thank you. Thank you. Thank you for taking a risk. Good job. Very, very good. Again, your goal is to get as many answers answered out loud as possible. So yeah, someone, when they typed it, I'm just going to show you the way someone typed. There's 2 different ways that people typed it. And I know you guys don't necessarily believe me that I'm actually asking people and then people are responding in chat. So this is someone's, where did it go? This is someone's answer right here, and I'm just going to copy it and put it over here. Someone said, Ms. Johnson, I don't know how to type it in the chat. I don't know how to type to the fourth. This is perfect, actually. And then someone else, ooh, that's bonus right there. Someone else put this right here. Let's see, this right here. I'm not putting your names on purpose because I don't, where does this go? It always hides behind my chat. Hold on a second. This is clunky. Copy. Someone else put it like this, right? And then someone else put this. And like, what? Where did they get this? Where did they get this? Why would they write it like this, right? Why would they write this like this? So all three of these are right. If you type this on Desmos for your quiz, that's right, that's right, that's right. So these two kind of make sense to me because they look like really the same. But this one here is a little bit different. And I'm going to put this one right here as my answer for that. Why would someone put 5 minus 1? Like, what's up with that? What happened there? I don't understand. Right? So in the chat, can you tell me why you think that person did that? Why would that person put that? Yeah. Where'd the 5 minus 1 come from? Like, what the heck? Like, couldn't he just write 4? I mean, he or she, haha, just kidding. He or she write 4? Like, why couldn't they just write 4? What was up with that? Okay, let me see. I'm trying to grab your extra credit. I mean, not your extra credit, your participation at the same time. Very good. Yes, yes, yes. Good job. Yes, absolutely. Look at you, fancies. Very fancy. Okay. Yeah, so let's see. People said, Ms. Johnson, the reason why they put 5 minus 1 is because the exponent, like you do one less to get that term. Exactly. So this person is saying, hey, Ms. Johnson, I know what you're going to ask next. Okay. So when we talk about levels of understanding, your first level was this. I'm just going to go over levels and check yourself off on where you're at. Because if you know where you're at, you know how to move to the next level. Okay. So number 1, geometric. They said geometric. That means multiplier. That's level 1. Level 2 is, can you write me a table? That's level 2. Level 3 is, can you write out the expression like this right here? Level 4 is, can you write your actual, your formula? Level 5, I'm going to just tell you right now, level 5 is knowing what I'm going to ask before I even ask it. So this person put this in anticipation of me saying, man, I wish I knew how to get from 5, this 5 over here, to this 5 minus 1 over here. And he said, just subtract 1, Ms. Johnson. How do you get from 5 to 5 minus 1? You just subtract 1. Wait. Is that true? I don't know. 5 minus 1 is 4. Check. 4 minus 1 is 3. Check. 3 minus 1 is 1, 2. Yeah, this has to be it, right? So like, there's levels to understanding, and you shouldn't expect yourself to go from I don't get it to I understand everything, Miss Johnson, because that doesn't even happen, right? It happens in levels. So this person who has this one right here, he didn't understand all of this on the first day. He probably understood this part, and then like maybe this part, and then maybe he got this the next time we talked about it, and the next time, and the next time. So yes, this is actually boss work right there. So if that's true here, then what would how do I put that here? Let me make this smaller so you can see both sides at the same time. How do I write that here in the function? Can you write me your function in there? How does that affect your function? Like, what would you write in there? What would you write for that? So yeah, I am going to wait a little bit because I do want to see a couple people trying this. So how does that affect this? What would I put as the exponent up here? What would I put as the exponent up there? What do you guys think? Yes, very good. Very good. Someone said you're going to put n minus 1 as the exponent. Exactly. Now let me try to make, let me put this in a different color here. N minus 1. Yes, you're going to put n minus 1. Exactly. Exactly. Okay. I got a couple people writing stuff in the chat. Looks really good. I will say when you are writing stuff in the chat, if you want this whole thing to be my exponent, I would kind of type it like this right here. See how there's parentheses around here? So when you're typing it in a computer, just put parentheses around your exponent to say this whole thing is my exponent. So very, very good. Very, very good. Very good. I got a couple people like really trying. I'm noticing it, and notice that your understanding is going to go way up just because you're taking that risk. All right, moving on. Okay. Okay, so that is my explicit. Done. Check. Okay, so I'm going to put a little highlighty box around it because that means I'm finished. And then it said, also write the recursive equation. So remembering our recursive equation, recursive comes in two parts. Okay, number one, starting point, and number two, the rule. Now, in my own opinion, recursive rule is easier to come up with than your explicit rule. Let me show you why. So the first part is your starting point. So starting point, Ms. Johnson? Yeah. So you'd say f of 1 is 1. So you want me to write f of 1 is 1? Yep. Okay. Now, the rule part is really right here. It says the next term is 3, and every term after that is found by multiplying the previous term by 3. So I'm going to give you two choices in the chat. Can you write this out in words or in function notation and try to see if that makes sense to you? So I just need the recursive rule part, not the f of 1 is 1. I want the notation part. Can you try that out for me? What would that be? And if you have to write it out in words, write it out in words. Yes, absolutely. So I would like the rule to be written here. So I need you to try. You could either write it out in words for recursive, or you can write it in our function notation. Either way. And it's okay to say, I don't know. And if you don't know, say, I don't know. Put I don't know in the chat. Because if you tell me that you don't know, guess what happens? Your brain's like, okay, wait, I don't know. I need to know. And then your brain will be like, okay, I'm ready. It's almost like a dry sponge waiting to get that information, right? Okay, so I have a lot of I don't know. So let me just show you. In regular words, yeah, good job. Person who put it in the chat, exactly. In regular words, it would look like this. The next term equals the previous term multiplied by 3. Wait, you just want me to write that out? Yes. Next equals previous times 3. Ms. Shelton, that's it? Yeah, that's it. And you told me that up here, right? Just multiply by 3, multiply by 3, multiply by 3. You told me that already. If you're trying to move to the next level of function notation, the way you would write next is just f of n. The way you write previous is f of n minus 1. Okay, so again, the n minus 1 part comes from, like, think about dates. Today is the 22nd. The day before was the 21st. Yeah, because it's 22 minus 1, right? And the day after the 22nd is n plus 1, right? So really, I want you to think about previous, next, as in today, tomorrow, yesterday, the way you figure out dates. So this is next, yeah, if you want to say next, is equal to previous times 3. So just put times 3. Yep, that's it. Got it? Okay, so this is actually finished. Let me put a little cute highlighter circle around this guy. And then that's our answer. So if this part doesn't make sense, this is what I need you to do. Tonight for homework, get to the part where you do understand, like, oh, Ms. Johnson, I knew how to write a table. I knew to write times 3. I knew how to write this. I just didn't get this part. I didn't get this exponent part. Cool. Play with that part over and over again. Ms. Johnson, I didn't even get how to write a table. No problem. Just start with the first term. It says 1. So we go 1. Wait, how do I get the next term? It says the next term is 3. Oh, 3. And then after that, it's multiplied by 3 times 3. So that'd be 9 and 27. Okay, so we completed this problem. Someone had asked to do number 5 from Ready, Set, Go. So this problem here, it says the same thing. In the next problem, you're given various types of information. Write the recursive and explicit functions for the geometric sequence. Finally, graph the sequence, making sure you clearly label the axes. Okay, so the only thing different here is that we're going to graph it, right? And from our earlier discussion, should we connect the dots? Should we connect the dots? Just guess yes or no in the chat. What do you think? Yay, nay? Yeah, it's a no. Very good. Ooh, someone yelled at me in the chat. Ooh, just kidding. Yeah, it's a no. It's a definite no. Ms. Johnson, why not? Because, like, if you look at 2, that's called your first term, right? If you look at 4, that's called your second term, right? So can you imagine that you have 2 little dots? And that's representing your first term and your second term. So here's a first dot, here's a second dot, just pretend, right? If you say if you connect these dots, like you're like, oh, Ms. Johnson, I know what to do. I'm going to connect these dots like this, right? And you connect it in some kind of curvy fashion. What you're saying is there's a term in between your first term and your second term, okay? There's not a term in between your first term and second term. So that's why these will all be discrete. If you do graph it, you would just say something along the lines of, this is a graph of my explicit equation, right? This is a graph of my explicit equation. Ms. Johnson, what's the difference? Well, if I graphed these, it would all just be a bunch of points, dot, 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 right? But if I'm graphing a function, I can plug whatever number I want in there. I can plug 1.2 in there and I can get out an answer. Okay. So when you're saying to connect or not to connect, all you're going to do is ask yourself, is there an in-between of those 2? So for these terms, no, there's not. Okay, so when I graph this, you'll see that they're not connected. So right now I'm going to pause, and I want you to pause the video and make sure that you can try to find at least one of the things that you saw earlier. Okay, so what I want to do first to do this problem, remember they're asking me to, number 1, write the recursive, number 2, write the explicit, and then graph it, right? So I really like tables because the tables help me be organized. So I'm going to make a table again. I'm going to kind of go out this much. Okay, so this is going to be my n, this is going to be my f of n, and then this is going to be the expression. And then now you know this is going to be my exponents. So you know where I'm going with this. So the first term, second term, third term, fourth term, fifth term. Oh, I always forget this. I'm going to do n here instead of fourth term, fifth term. So that's n. So the first term it says is, oh, it's 2, 4, 8, 16. So 2, 4, 8, 16. Okay. Just really quickly, one of the things that I keep wanting to talk about that I've neglected is this guy right here. So before I move on to that one, I want to show you, because I haven't shown you, and I want to remind you that, Ms. Johnson, how come you keep not putting stuff here? Well, it's because in reality, that's just that one, right? But Ms. Johnson, will it still work? Well, I don't know. Let's plug this in, right? So over here, it would say 1 times 3 to the 1 minus 1, right? And if I calculate that, right, 1 minus 1 is 0, right? So that's 1 times 3 to the 0. Oops, not 6, 0, right? And if you remember, do you guys remember what 3 to the 0 is? What is 3 to the 0? Yes. Okay, good, good, good. I know your gut kind of wants to say, oh, I know what this is. It's 0. No, please don't fall into that trap. That's a really good trap that I like to place for people that are not paying attention. It's 1, right? It's 1. And if you don't remember, I have a video, it's called Exponents Review or something like that, where I explain why it's equal to 0, right? So this is actually just the number 1. So wait, Ms. Johnson, you're saying that's 1 times 1? Yeah. And what's 1 times 1, guys? It's 1. So, oh, it still works even for this guy? Yeah. So I was avoiding that conversation, not really avoiding, but I wanted you to focus on the exponent part and not get bogged down by your 0. So I just want to make sure that you all see that it works regardless of all of these things, okay? And the structure is still there, right? You see that structure, a times b to the exponent, right? Okay, so same thing goes here. I'm going to do this problem really quick. As you can see, you can kind of already tell what your multiplier is going to be. That's the first thing that I want to pop out in the very, very beginning. What's the multiplier in this case? What do you see as the multiplier in this case? Yeah, very good. Very, very good. So in case you don't know how to find the multiplier, I'm gonna walk you through step by step just to make sure that everybody's on the same page. Okay. I'm just giving credit. Okay. So in case you don't know where the multiplier is, I do bottom divided by top. I do bottom divided by top. So I say in my brain, this is Ms. Johnson in her brain. I do bottom divided by top. So in this case, it's 4 divided by 2, which is 2. So that's my multiplier. I guess I should write that, label that. So that's what I'm doing in my brain. So if you say my multiplier is 2, that means I can multiply this by 2. Yep. To get 4, yes. And 4 by 2 to get 8, yes. And 8 by 2 to get 16, yes. So that's multiply by 2, multiply by 2, multiply by 2, check. So if you were paying attention earlier, you know exactly where they show up here. You know exactly where they show up here, okay? If you already know where they show up, make them show up there, okay? If not, follow me over here, right? So then I would like you to write the expression. So the first guy is just going to be that 2. The second guy is going to have that 2, except for now we're going to multiply that by that 4, right? Sorry, to get 4. You're going to multiply by 2 to get that 4. The third guy is going to be the same, where you have that 2, and then you're going to multiply by not 1, 2, but 2 2s. Haha, I said 2, 2, right? And then so on and so forth. Hopefully you are all seeing the pattern. Oh, Ms. Johnson, I see the 2. It's all the same. And some of you are like, Ms. Johnson, there's a lot of 2s. Now, that's why I use different colors. So this 2 right here is going to be the same as our earlier one, right? So then now what I'd like you to do is try the expression. Yes. Yes, actually. So now I would like you to write the expression. And some of you are like, Ms. Johnson, can I just collect all the 2's into one exponent? Yeah, absolutely. Collect all the 2's and put them under one exponent. Why not? They're the same bases. Okay. Okay, so some of you are like, okay, Ms. Johnson, so you want me to put 2? Yeah, and I'm going to use a different color for this one, and you'll know why. There's 2 2's here, there's 3 there, and there's 4 here. And if you look, this guy is exactly the same this time. Oh my gosh, this 4 matches this 4. So you already know what this expression is going to be, right? What is this expression going to be? What is this expression going to be for n? Try that out. Try it for me. What do you got? What would the expression be this time? Like, how would I write the n in there? Right? So the question that I asked you before was, what do you see that's the same in all of these? And you're like, oh, Ms. Johnson, I see this is all the same. Okay, so let's start building that explicit function, right? Our explicit function for this one is going to be f of n is equal to now. What? What? What is the same in all of these? What is the same in all of these? In all of these, what do you see as the same? Can everybody say that? Yes, very good. Thank you, thank you, thank you. Lots of people here. Yes, I see the 2 is the same in all of these. Yeah, sure. Okay. Now, that 2 is the same. Now, because I have this exponent here, and I have the same exact exponent there, right? The n is the same as the exponent. Does it make sense to you that I would write just 2 to the n? Does it make sense to you that I would just write 2 to the n? Now, some of you are like, wait a minute, Miss Johnson, wait. What happened to this guy? Like the 1, like where's he? Well, you could write it in a different way, and hopefully this is not going to confuse you, but it just still makes sense. Your alternative to writing this is like, if you look here, what's the same here? And you're like, that pinkish 2. Okay, let's write a pinkish 2, right? And what's changing? Well, you're like, well, the 2's are changing. Oh, good. How many 2's are changing? So we write another 2 to represent these 2's. And if you look here, there's 3 blue 2's. That sounds funny. There's 3 blue 2's, which if our n is 4, and we have 3 of them, oh, it's just n minus 1 again, Ms. Johnson? Yeah, it's n minus 1. So I know it doesn't look like it, but this guy right here is the same as this guy right here. He's the same thing. It's the same value. This guy looks different than this guy. This guy's more broken up into pieces. Does that make sense? 2 times 2 to the n minus 1. So you can actually see all these pieces here. You see the pink 2? Yeah, Miss Johnson. You see all the blue 2's? Uh-huh. And it's just of n minus 1. So 3 of them, and then there's only 2 here. So this one got condensed because these numbers were all the same. Okay. Okay. Our recursive function, very similar. We would write the first term. So can you guys write the first term for me? Write the very first term. So it looks like this. F of something equals whatever. Give me the first term. Can you put that in the chat? So my first term is the first line. My first term is the first number, right? So I'm going to put 1 right here. And what is the first number? What's the first term that they gave me? Very good. Come on, guys. You can just try. It's okay. I know it feels funky, but just try. Very good. Very good. Very good. Good, 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 good. Very good. Yeah, no, that's right. That's right. If you said f of 1 equals to 2, you're right. Okay, f of 1 equals to 2. What does this mean again, Ms. Johnson? Even though it says that, it just means in English, first term is 2, right? And the first term is 2. Look, he's right there. He's my first term. Very good. Okay, and then I would have to write my rule. So my rule is, okay, now go back up here. My rule just says next equals previous times 3. Wait, where'd you get the 3 again? Oh, yeah. Wait, next equals? Can you give me it in words really quick? Can you give it to me in words? Can you give me the rule for recursive in words? Oh. Okay. So can you give it to me in words? I'm going to start you off. Next equals previous. What? What is missing over here? And I'm going to move this guy right here. Nope. I need you to be part of this N. There it goes. Yes, very good. Yes, yes, yes. Times 2. Okay, so if you look, that 2 is the star of the show. This 2, this 2. You see the 2s all over the place? Not this 2, by the way, because that 2 is just the first term. So all of these places have my 2s everywhere. I see these 2s everywhere. Yes. Oops, I shouldn't have done that one. Not this pinky 2 over here. Very good. Okay, so if I wanted to write it in like f of n minus 1, I'm going to go f of n equals to f of n minus 1 times 2. Again, I'm accepting both of these for your next quiz. I'm accepting both of them. Really, Ms. Johnson? Yeah, I'm accepting it for every single test quiz coming up. Now, I might take off a point if you don't move over here to function notation, but it's like 1 point. So if you can give me next equals previous times 2, you're good. Okay. All right, let's move on to the graph. So if any of this part didn't make sense, go back and watch this. Pause it. Do the problem again. Even if you're writing down exactly the same things over and over again, you're gonna get knowledge. Okay, but you have to write it out. Okay, I'm gonna write this as 1. I'm gonna put a 1 here and a 1 here, just so that everybody knows that it's 1 and 1, right? And I don't draw my axes in because it gets all funny. Okay, so I'm going to graph all of these points right here, and then you're going to see, and you should tell me, Ms. Johnson, don't connect it. And you should know why we shouldn't be connecting it. Okay, so 1, 2, big dot, 2, 4, big dot, 3, 8, 1, 2, 3, and then this is 8, big dot, 4, 16, 8, 9, 10, 11, 12, 13, 14, 15, 16, big dot. Now, Ms. Johnson, you don't want me to connect those points? No, please do not connect these 2 points. Ms. Johnson, why don't you want me to connect the 2 points, these points? Because remember we talked about discrete versus continuous? There's no in between, okay? All right, with that being said, hopefully that makes sense.